In this video, we'll talk about accelerations of a uniform circular motion. Again, recall our previous calculation. The acceleration is given by this expression here, and ax is given by that, ay is given by this. So let's write this down. Okay, so ax cosine omega t, and ay equals sine omega t. Okay. Now let's also recall the x and y expression. X equals r cosine omega t. Y equals r sine omega t. So this term, r cosine omega t, is simply just the x. And this term is y. So we get ax equals negative omega squared times x, ay equals negative omega squared times y. And if I write this expression in vector form, then a vector equals negative omega squared times r vector, the position vector. So these two vectors are pointing in opposite direction, since negative omega squared is negative. So if there's a acceleration, let's say, point this way, then the position vector must point the other way. It's the r vector. Okay, and let's look back at the picture here. So the velocity vector is pointing this way, position vector is pointing this way. So the acceleration vector must point along this direction. That must be A. So A only have this radial component. Velocity is along tangential direction, and there's no tangential component for acceleration. So A is along radial direction. So in general, the A is A radial times the radial component of the unit vector for the radial component, and tangential component times the unit vector of the tangential component. So now since we only have radial component, so A is radial component and the tangential component is 0. Okay, so now let's see what's the magnitude of this A. So A's magnitude equals ax squared plus ay squared. And if we do this square calculation, we'll see omega power 4 r squared plus omega to the power 4 r squared. And sine square and cosine square cancel out. They add up to be 1. So I neglect it in the expression. So it's actually this one. Sine square plus cosine square. So that gives us omega squared times r. That's the magnitude of the acceleration. And we also know that the for tangential velocity and the angular velocity, they have this relation, v equals omega times r. So if I replace omega by v over r, then I get v squared over r. So these two expressions are equivalent, either omega squared times r or v squared times r. They both give us the magnitude of the acceleration for a uniform circular motion.